So what we're going to do today is we're going to talk again about the net change, because the net change is integration. If I want the area, you'll see on the homework it says area or total area. That means I have to pay attention to where I'm above and below the x-axis so that I can get the total area and not just the integration, which gives me the net change. So here are two different formulas for the net change. The one that we do and have been doing is this one right here, which is just basically integrating. And whatever shakes out is whatever shakes out. So let's go ahead and use that second part of the theorem, the one that we're more familiar with, to do the integration. So if I'm asked to integrate these, I'm really asking for the net change. Not the total area, but the net change. And I need to pay attention, whether it is on the test, or on the homework, or in here, whether or not I need to add the plus c, or whether or not I'm going to get a nice numeric value. On my first example on A, do I expect to do a plus c, or do I expect to get a numeric value? I'm going to get a plus c because I don't see the limits of integration. So I don't see anything right here or right here. There are no limits of integration, so I know that my final answer is not going to be a numeric value. It's going to be a plus c. It's going to be a formula with a plus c. The first thing I always do when I look at these integrations is I rewrite it in something I can see visually easy, which is when I see the square root of x, I'm going to write that as x raised to the 1/2. Bless you. The same thing is going to be true when I see 1 over. So when I see 1 over, I'm going to make it as a negative exponent. So I'm just going to simply rewrite these so that it makes it easier for me to do the power rule of integration. So this is going to be equal to the integration of x raised to the 1/2 minus x raised to the negative 1/2 dx. I not only do this so that I can use the power rule of integration. The power rule of integration says when I integrate, I need to add 1, because when I'm doing derivatives, I subtract 1. But that also means I need to do 1/2 plus 1 in the denominator. Now remember, this is not part of the original integration. I'm just doing it there so you can see I'm reversing the power rule. So I know my first term is going to be equal to, well, 1/2 plus 1 is 1.5, or 3 over 2. So 1/2 plus 1 is 3 over 2. 1 over 3 over 2 is 2 over 3. So my coefficient on my first term is 2 over 3, x raised to the 3 over 2. Now the second one we should be really familiar with because we keep seeing this one over and over and over again. I'm going to add 1 here and then divide by negative 1/2 plus 1. We see this over and over and over again. So negative 1/2 plus 1/2 is going to just be 1/2. So it's going to be plus it's going to be minus 2 raised to the 1/2. And this one needs a plus c because I don't have my limits of integration on there. What kind of questions do you have for me? Yes?
Would it not be at minus the negative 2?
So let's do the derivative. So the great thing about when we integrate, we can always do the derivative and see whether or not we get back to where we started. That's the great thing about these, is we always can undo it. So let's do the derivative of this. Let's do d dx of 2 to the 3rd x raised to the 3 over 2 minus 2 x raised to the 1/2 plus c. So when I do the derivative, I'm going to multiply that power by the coefficient and then subtract 1 from it. So this is going to be equal to 2 over 3 times 3 over 2, x raised to the 1/2. So I'm going to drop it by a power. and then minus 2 multiplied by 1/2, and then x raised to the negative 1/2. Is that where I started? Yep. So my answer is right here. What other kind of questions do you have for me? On example B, am I expected to get an answer numerically, or am I expected to get a plus C, the formula with a plus C?
Numeric.
I'm going to get a numeric. And how did you know it was numeric?
Because it has a limit range.
Because I have the upper and lower limits. So I'm just going to integrate this. If I ended up with sine as the answer, what must I have started out with? Negative cosine. If I ended up with cosine as the answer, what would I started out with? Negative sine. I'm going to evaluate this from 0 to pi. There's always going to be my upper limit first, so this is going to be equal to negative cosine of pi minus the sine of pi. And if I look at my example, this is f of b, the way we defined it. And then minus the negative cosine of 0 minus the sine of 0. This is the f of a by our definition, upper minus lower. What is the cosine of pi?
0.
That's sine of pi. So it's negative 1. So this is going to be equal to negative 1. And then minus the 0. Cosine of 0 is 1. So minus a 1. Then minus 0. Sine of 0 is 0. So this is going to be equal to 1. Negative 1 and negative 1 make it positive 1. And same with the other. So my net answer is 2. How was that? Is that okay? What kind of questions do you have for me? Yes?
What is going on?
I'm not sure what you're asking me. I'm not sure what you're asking me. I mean, like in general, it's snowing, it's Friday the 13th, someone's playing Jumanji, and the cauldron in Yellowstone is expanding.
No, I meant in math.
Oh. We're doing integration, so we're undoing the derivatives. Yeah? No? Let's do a couple more examples, and hopefully you'll start to kind of feel what's going on. Hopefully? Okay.
You go back over the, yeah, right there.
Oh yeah, absolutely. What other kind of questions do you have for me besides what's going on?
How's the SAT coming?
We'll be happy. All right, so this one. I'm going to look at this one. And I'm looking for pattern recognition on this one. So I'm going to get out my little note card. So all you're going to do is get out your little note card with all the derivatives on it. All of your derivatives. When you look at all of your derivatives, which one has, it looks like it's probably inverse of sine, yeah? Do you all agree that kind of looks like the inverse of sine? If I do the derivative of the inverse of sine, I'm going to get 1 over the square root of 1 plus my angle squared, right? 1 plus my angle squared. So this kind of looks like it, doesn't it? Does that kind of look like what I need? Yeah? No? Okay. If it doesn't look exactly the what I need, then I'm going to introduce use substitution right now so we don't even have to do it next week. Yeah. So use substitution allows us to make stuff that looks really difficult fairly easy. Do you remember in pre-calc 1 when you did the composition of functions? Composition of functions is what we do when we do the chain rule, right? We're doing the chain rule, the composition of functions. So we're going to try to make our life as easy as possible. What if I said to you, if I did the derivative of that, what would I get if I did the derivative of that?
0 plus 12t.
So I'd get 0 plus 12t. Okay? That's kind of that, but not quite. What would I have to do to make that equal the derivative of the 1 plus 6t squared? So let u equal 1 plus 6t squared. U prime would be what? 12t dt. Do y'all agree? So right now what I have is from 0 to 4, I have 1 over u, I have a 3t dt. Square root. Yes?
Isn't it just the u prime negative 4?
Is what?
95 times. I'll see where you're going with this.
Yes.
Would the u be squared on the bottom?
No. How are we doing? So if I let u equal 1 plus 6t squared, then I get u prime is equal to 12t dt, which I'd have 1 over u, and then I need to do a replacement for 3t dt. Do you all agree to that? No, I don't want to do v. It's all just u prime.
So we're trying to get a 3t over like one of those.
So now what I need to do is I need to get a replacement for the 3t in terms of u.
1/4.
So if I did 1/4 u prime, I have to do 1/4 of both sides, right? Then this is going to be 12t divided by 4 dt. It's totally fine. Do you all agree to that? Okay. So now we have a replacement. This gets replaced with this. Yes?
And then u prime under the radical, or just the u?
Just the u.
Okay.
So now I have a replacement. Let me erase all of this stuff. So this is going to be equal to, let me do this in black. This is going to be equal to 0 to 4 of 1 over u, 1/4, I'm going to write it as a du instead of u prime. Oh, I keep forgetting my square root. Questions for me so far? Yes?
Why is it 1/4? Why is it u prime over 4?
Sure, I can write it as u prime over 4, but I'm going to write it as 1/4 du. Yes?
Why did you write? Why did you choose to write the u instead of putting it in there?
Okay, so with u substitution, when I start to introduce the variable u, I have to change my dt to du. So I need to have a replacement for that 3t dt. And the way I have that replacement is that for that 3t dt, is 1/4 u prime or du. And when I do 1/4 to one side, I have to do to the other. So it is 12 t over 4 dt is equal to 1/4 u prime or du. So do you see a 12 here? What do you see there? So I need a replacement for 3t, but my derivative is 12t. But I don't have 12t, I have 3t. So I have to make an adjustment somewhere because I need an exact replacement. And so I have to do a replacement is, to get that to be a 3, I need to divide it by 4, but I have to divide the other side by 4 as well. How are we doing? What other kind of questions do you have for me? Yes?
Using the denominator u primes.
Those are square roots. Are they that bad?
You do the square root and then you do that little line on the end. I can't tell if that's where the square root is.
Oh, no, that's where my square root ends.
Okay.
So I do the line to tell me, oh, okay, that is.
Yeah, that's 3. I got it.
Yes, I do the square root to end there to remind me where it ends. Okay, what other kind of questions do we have for me?
Now we have to put it in terms of dt again, right?
Okay, so this is one of 2 options, okay? You have one of 2 options. And that's why I've stopped. Option A is we just do the derivative as is, but we have to change our limits so that it matches up with our u. Option B is we do the derivative and then we go back to what we said u was. So I'm going to do the first option, and then you can see how it's not going to matter, okay? So I have to change these limits here because I changed this. I have to change my limits here because I changed from 1 plus 6t squared to u. So the way that I do that is I just plug in those values and figure out what u would be, the lower and the upper. So if I plug in 0, u is going to be 1. And if I plug in 4, what is u going to be? What is it? 97? Okay, so my next step over here is now change my limits. So this is going to be equal to 1 to 97. I'm going to factor out the 1/4. Are you all okay with me factoring out the 1/4? Because it's just a constant, I'm just going to factor it out. I'm going to write u, since you all love my square root, as u raised to the negative 1/2 du. Now let's integrate.
Where did the 1 plus u prime appear?
So u prime is du.
Just factor out the
Oh, you got it.
So now I just integrate. So how do I integrate this? So I add a power, or add 1, and then I divide by that, like I normally do. And so this is going to be equal to 1/4, 2 times u raised to the 1/2. Evaluated from 1 to 97. Yes.
You have to plug u back into.
No, so since I changed my limits from the lower limit and the upper limit on my integration, my limits of integration, I don't have to go back and plug in what u was.
So you figured it out.
We've already taken that into account. So I just do, this is just going to be equal to 1/2 the square root of u, evaluated from 1 to 97. Which is just going to be equal to 1/2 the square root of 97 minus 1. And then whatever that plays out to be. How was that? Yes. And the cauldron's going to explode on us.
Why is it -1? Is that because that's our lower number?
Yeah, it's square root of 1. Okay. So before you ask any questions, let me explain that if I didn't take this step up here in yellow, see that step up in yellow? Then when I replace stuff with u, if I don't take this step in yellow right here, let me do that in blue. If I don't take this step where I've replaced my upper and lower limits of integration, then I need to note this as u1, u2, and I'd still have 1/4 u raised to the negative 1/2 du. Because that would remind me that when I get done, erase all of this. When I get done, because I know what this is going to be, it is going to be 1/2 the square root of u, u1, u2. If I don't want to change the limits of integration, then I'm just going to have u1, u2 as placeholders so that I can do this as 1/2 the square root of 1 plus 6t squared, and then I go back to my original limits of integration, which gave me the exact same answer if I would have changed the limits of integration at the beginning. Now, what kind of questions do you have for me? Yes?
If you have the 97 and 1, you just put the 4 and 0 into the 60 function.
That's how I got the 97 and the 1. Yep. And I changed my limits of integration. Like I said, option A is you change them. Option B is you don't. If you don't change them, then when you get to the very end and you get this, you have to change everything back into what you started out with. Yes?
So generally, how do you decide what to set u to be?
So when you're trying to decide what you set u to be, does this look like, right? That look like the sine inverse? Didn't that kind of look like the sine inverse? But if I would have had the sine inverse, and we think it could have been 3t, right? That's what we think it could have been. If we think that's what it could have been, let's do the derivative of this. When I do the derivative of this, what am I going to get?
3.
I'm going to get 1 over the square root of 1 plus, is it 1 plus or minus?
Minus.
Oh, see, then it wouldn't have been the sign anyways.
Yeah, close.
Yeah, because I would have done 1 over the square root of 1 minus 3t, the quantity squared, and then times 3, which is not what I have. Now, if I would have done, nope, that's not what I wanted to do. If I would have chosen a different u, substitution, on this one, it would have worked out just as well.
So I'm going to use like 3t as a u.
So you could have used, let u equal the square root of 1 plus 6t squared. So if you would have used that, what would your derivative have been? Raised to the negative, and then what do I needed here? Okay. It is a little messy. U substitution is a little messy. What about D? How would I do D? Do I expect a numeric value or a plus C? Then do D. Straightforward, no U substitution. Now give me the integration. When you integrate it, what'd you get?
1/4 x to the 4th minus 2/3 x to the 3 plus 2x squared.
Y'all agree? From negative 1 to 1, what is your final answer?
-4/3.
How was that? Have a great weekend. If I don't see you later today, again at 10:30, noon, and at 2:30.